This video will cover section 2.3 on functions, and we're going to see a lot about functions, and a lot of this material is going to look similar because some of the functions are like some of the equations we've already solved. Alright, so a relation is a set of ordered pairs, and so remember, an ordered pair is simply the x and the y value to make a coordinate, and then if I have a set of those, with little braces makes the set, and then you just have, multiple ordered pairs like this, and you can have any number of them. Alright, so anything one or more ordered pairs would make the set. Now, if I have a function, alright, a function is a relation, so it's a set of ordered pairs, but in this relation, all of the x values are different. Alright, so for each distinct value of the first component, there's exactly one value of the second component, and that means for every x there's only one y value. None of the x values repeat. So if you have a relation where the x values repeat, then it is not a function, it's just a relation. Alright, so we're going to look at these three relations here on number 1 and decide if they're a function or not, and to do that we simply look at the x values and see if any of them repeat. Alright, so looking at relation f, alright, I have a 1, a negative 2, and a 3. Since all of those are different, then I can say this is a function. Looking at relation g, looking at just the x values, I have 1, 1, 1, and 2. So in 3 of the ordered pairs, they have an x value of 1, and since those are the same, or they repeat, then we would say this is not a function. Looking at relation h, we have negative 4, negative 2, and negative 2. Since these two x values here are the same, then we will say this is not a function. Alright, in a relation, the set of all the values of the independent variable x is known as the domain. So the domain is just the set of all x values. And independent simply means that I'm just going to fill in values for x. And it has no, they're not affected by anything. I pick whatever I want to. And then the set of all values of the dependent variable y is the range. And so really it just is easiest to remember if you say the set of all y values. Alright, so we're going to look at a couple of relations, determine what the domain and range are, and then decide if they're a function. Alright, so if I look at A, this is a relation. The domain is going to be a set, so I make little braces, and then I just pull out all of the x values. So that'll be 3, 4, 4, 6. Now if any of the values repeat, there is no need to list them twice. We're not looking for the quantity of x values, we're just looking for each distinct x value, and that would be 3, 4, and 6. Then for the range, we want to know the y values, so that's going to be negative 1, 2, 5, and 8. Alright, when I look at the x values, since 2 of them are the same, this would not be a function. Still a relation, just not a function. Alright, looking at B, this first oval is going to contain our x values, and this second oval is going to contain our y values. So if we look at the x values to get our domain, there's no, you don't have to list these in any specific order. They don't have to be in numerical order from largest to smallest or anything. Just as you see them, just make sure you get them all listed in there. So negative 3, 4, 6, and 7 makes the domain. And then the range is going to be 100, 200, 300. Alright, now to determine if this one is a function, you're going to look at the arrows coming off of each of the x or domain values. If there's more than one arrow coming from one of the x values, this is not a function. So when I look at 4, it only has one arrow, 6, only one arrow, 7, only one arrow, negative 3, only one arrow. So we can say this is a function. If any one of those had multiple arrows coming off, say the negative 3 had an arrow that went to 200, Alright, then that second arrow coming from -3 to a different y value would make it not a function. Alright, looking at letter C here, the domain is going to be -5, 0, 5, and the range is simply 2. Alright, even though there are 3 2's listed there, we're not worried about the amount of 2's. If they repeat, 1 is all we need, just each distinct y value. Alright, because all of the x values are different, we can say this is a function. Alright, now we're going to look at a couple of graphs, alright, of some relations. And we're going to pull out the domain and range, and then we'll go back and look to see how we can determine how a graph is a function or not. Alright, so when I look at the first one, the domain is going to be all of the x values of the different points. So -1, 0, 1, and 4. And then the range is going to be the y values. Remember, it does not matter if the order, as long as you get all the y values listed in there. Alright, looking at the second graph, this graph is an oval shape. Alright, and remember, to find the domain, you're looking for all of the x values. So think about all of these points, alright, on this graph and their x values. So if I start here at the smallest point, at the furthest point to the left, alright, that would be the smallest x value, would be -4. And if I move to the right, and if I go up or down, alright, I hit a point on the graph. So for that x value, there is some y value. And if I keep moving right, anywhere that I move up or down, I'm going to run into the graph. So all of these points have x and y coordinates. So anywhere between -4 to 4, alright, all of these, alright, I'm going to run into some part of the graph. So there, all of these values would be in the domain. Make sure you put the brackets around them. So we wrote it in interval notation. It's not just a set of random numbers, but this is any number between -4 to 4 is part of the domain, and we're including -4 and 4 because they are points on the graph. Alright, then if we look at range, alright, range, remember, is the y values. So if I follow along this y-axis, if I go to any point on that y-axis and move left or right, I'm going to hit a part of the graph. So my range is going to be any value between -6 and 6. If I pick any number between there, including these two, and I move left or right, I'm going to hit some part of the graph. So it's going to have a corresponding x value. Alright, next is the graph of a linear equation. Alright, remember that even though there are arrows and we only see this little portion of the line, alright, these arrows say that this line goes on forever and ever in both directions. Alright, and so does the x-axis and the y-axis. Alright, so if I'm way down here somewhere, I still have a point. It still has an x value. If I'm way up here somewhere, alright, my point still has some x value. So the domain for all linear equations is going to be -infinity to +infinity. Because this line goes on forever, there's forever will be an x value. And it is the exact same thing for the range. If I move along any part of this y-axis, if I move left or right, I'm going to run somewhere into the graph of that line. Alright, now anytime I have a linear equation, so you want to write this down and remember it because we're going to see it a lot. It's going to be on the test. Alright, anytime I have a linear equation, the domain and range are going to be -infinity to +infinity. Any time. Always. Alright, so make sure you might want to write that down and highlight it and circle it and so on and so forth. Alright, looking at D. Alright, this is the graph of a quadratic equation. It's in the shape of a parabola. Remember, these lines say that this goes on forever. Alright, and so it just keeps getting wider and wider and wider and wider. So for the domain, it's going to be negative infinity to positive infinity. And then the range, alright, with a parabola, there's a bottom or a top, depending on what the equation is. Here, there's a bottom. So the lower value is going to be -3. And then we keep going on in the positive infinity direction. Alright, now, if I have a graph and I want to know if it's a function, I can use the vertical line test. And so what I do is I draw a vertical line. Alright, if I can draw a vertical line anywhere in the graph and it touch more than 1 point. So if I can draw a vertical line, remember vertical lines are the ones that run up and down. Alright, if I can draw one of those anywhere on the graph and it touch more than 1 point, then we'll say it is not a function. So if I look at the first one, there are only these 4 points. They do not line up in any way vertically. And so this right here, if I drew a vertical line anywhere in here, it would not touch more than 1 point. So we would say this is a function. If I did the vertical line test here on B, there are lots of places where if I drew a vertical line, alright, it would touch more than 1 point. So that one is not a function. Here, if I draw a vertical line, so straight up and down, I would only hit one spot no matter where I drew it. So we would say this one is a function. Alright, and for D, the exact same thing. It is a function.